So, welcome, welcome, welcome. Congratulations, you've all hit the jackpot. Unbeknownst to you, you have picked the best elective. This is the best elective. Why is this the best elective? Because this teaches practical skills. This is a course where we are going to learn how to use Linux. That's right. Good, honest, hardworking Linux operating systems. And we are going to learn Git. Linux and Git. This is the Linux and Git class. Both of these are really, really strong job skills. We're also going to do stuff like, how do you actually make a software portfolio? Right? You know, the thing that you, here, I'll get that for you. The thing that you ostensibly need to get a job, that thing that they never actually teach you how to do. Guess what? We're going to teach you how to do it.
Awesome.
Yeah. So that's what this course is. This course does not have an exam. Hold your applause. No, you can applaud if you want. So the structure of this course, we have 13 assignments. You can kind of think of them as like lab exercises. There's time allocated in class to work on the assignments. And there are 13 of them. The lowest graded assignment is dropped. So your actual final grade is composed of 12 of these things. And yeah, it's, 13 assignments, 13-week semester. You've got roughly one of these things due per week. They're not intended to be murderous, right? It's actually kind of nice for me. I'm normally stuck teaching JavaScript, Java, and PHP, all three of which have really high failure rates. So it's kind of nice for me to teach something that's not that, right? And like I get to be, my wonderful bubbly personality and not the guy who's wielding the axe. But that's okay. So, yeah, we're gonna do Linux. We're gonna do Linux. We're gonna do Git. It's gonna be wonderful. It's gonna be awesome. It is not my expectation that any of you install Linux on your own machines. This is a question that often comes up when you study Linux. It's kind of like you don't have to do that, but if you happen to have an old computer that you don't have, nothing's on it that is useful to you, right? And you wouldn't mind wiping out the operating system, bearing in mind you will lose everything that you haven't backed up elsewhere when you do so. Installing a fresh Linux installation is a very informative thing to do. It's a very useful thing to know how to do. The process is fairly similar if you create your own Linux VM as well. Now, all of the Linux stuff that you'll be doing in this class, we will be doing through a virtual machine, right? So a virtual machine is a little tiny sandboxed operating system. Basically, it's a program that allows another operating system to be running on your system. But unlike something like Windows subsystem for Linux, you're not kind of in this weird the semi-state between being Windows and Linux. It is a proper, fully featured Linux operating system, right? So, Windows subsystem for Linux isn't going to cut it for us for this course. So we're going to have to use the actual VM. Okay? It's a bit of a bulky download. If you guys saw the announcement before the first class, it said, please, please, please download it ahead of time because it's 4.5 gigs. Speaking of which, I should probably get it downloaded to this thing, shouldn't I? Here. Should actually log in. I got too excited. Here we go. So the virtual machine is not standalone software. It requires the use of VirtualBox as a sort of operator for the operating system. Oh, suppose I would need to enter my password correctly. So VirtualBox is available on the lab machines through, I believe it's, in some labs it's native installation, in some labs it's through Mohawk apps. We'll have to sort of, I'll have to check to see which one of those it is here. But basically, you load in the VM, you can allow it to take over your entire monitor, or you can keep it windowed if you prefer. But it's a full operating system. You can load up a browser and view the course pages from within the VM. Once you're in VM mode, you don't really have to switch back to Windows, right? For me, once I've shown you how to get the VM, most likely I will skip that process myself because I'm one of those guys who's in the cult of Penguin. I have Linux Mint, which is the actual, not only, well, the version might be the same, but I have Mint on this laptop, so I'll probably use that. Saves me the trouble of, fiddling with the VM, right? Again, if anybody wants to install Linux on any machine, I am happy to help you to do so. But it's not like part of the curriculum, if that makes sense. Right? Are there any questions so far?
Is the VM able to download on Mac, or do I need a Windows computer?
See, this is something of a sticky problem.
Okay.
The new Macs that have the Apple Silicon processors, that processor does not have the virtualization accelerators that the Intel chipset does. So VMs basically don't work on them. You might get something to work, but I can't guarantee the quality. So that's bad. Here's the silver lining. Mac OS is already a Unix-based operating system. At least for a period of time, we will be studying how to use the bash shell. This is something that is already on your Mac. You just have to know how to access it. Actually, if you just open your terminal and type bash, it'll bring you to the bash shell instead of Mac's sort of inbuilt one. Does that make sense?
Yeah.
So you should be able to do, you should be able to follow on at least the first 3 weeks of class without issue. Some stuff will be a little more Linux specifics, but even once we get to Git, this is like a command line class. So if you have the right command line, it's kind of like, I'm not particular that you're running Mint specifically, right? There was one person who emailed me in advance of the class and says, hey, I'm running Ubuntu, is that okay? And I'm like, well, you're going to do well in this class. Yes, Ubuntu is very good. Yeah, so yes, we should be able to work something out. The VM might not work, that might not matter, we'll see.
All right. Thank you.
You're welcome. Any other questions? Very good. So, I don't care about stocks. Stop it. Thank you. So, this is a rather long class. This class has been booked for 4 hours. I'm sure everybody noticed that. So, let's discuss the format of the class itself before we get any further. When a class is 4 hours long, I normally allow a half-hour break in the middle of it, right? Like, in theory, you're supposed to have like 10 minutes an hour, right? I usually skip that for a 2-hour class because, you know, it's kind of like short enough that it doesn't, you know. But like, for a class this long, if we take those 2 minute, those 3 10-minute segments, and we push them together, you might actually be able to eat some food. So that's what we'll do. At some point during the middle of the class, where it's convenient for the class's flow, I will call a half-hour break, and we'll, you know, reconvene in a half hour. Does that make sense?
Yeah.
Agreeable plan? Good. On a typical week, how it's going to work is the front half of the, probably the first half of the class before the break will be, you know, the taught material, the sage on the stage, as it were. And then the allocation for individual work and exercises, that will be in the back half, hopefully, right? 4.5 gigabytes, right? Your average container that does the same thing, running like Alpine Linux, for example, under 200 megs, right? This is small enough that you can kind of just download them on demand, actually, right? So it's a stripped down version of Linux, but it's not intended to be a full operating system, right? Full operating system. For one thing, no GUI, right? None of this. Command line is basically the only way to interact with them, right? It's a little tiny virtual machine that's only really intended to run one program or two programs, a small collection of programs. It's an operating system that's made for a couple of programs, right? In order to do anything useful with a Docker container, you have to know how to CLI. You have to know how to use a command line interface, right? And that is hopefully part of what we're going to learn here. Sound good? Yeah, Docker is currently revolutionizing things the same way that virtual machines revolutionized things 15 years ago. Like, it's getting very big. Docker is doing very well. So, very good. So, this is not only feedback from employers, this is also feedback from our graduates who we send out into industry and say, hey, how's it going in industry? And they're like, well, we really wish you taught us Git because we use it every day for everything. It's kind of difficult to explain, like, why this stuff is so important without having plunked you into an environment. How many, have you guys done co-ops yet, or are you about to go out on co-ops? No?
I did.
Yeah. You did one? So you worked for a software company?
Yeah.
Did they use Git?
We used the Slack one, but it was based on Git, the Slack one, I don't remember.
Slack? Slack?
The
Oh.
Atlassian Suite one, I forgot the name.
But you worked.
Bitbucket.
Okay. Bitbucket. Yeah. I think Git is still like the back end for
Yeah,
Bitbucket.
but like we use it, not GitHub, but Bitbucket.
I mean, you can't blame a company for not wanting to use GitHub, right? Like, we'll be using GitHub here because it's overwhelmingly the most popular one, but so Git is like the back end of the repository software, but you'll have a lot of different front ends to it. GitHub is one of them. Bitbucket is another one. GitLab is another one. These are all, like, you know, it doesn't super duper matter what the front end is if you understand how the back end works. The back end is the same in all cases, right? So the knowledge here, we'll try to keep it transferable to other platforms, but there are some things that'll be very GitHub specific, like GitHub Actions that we are going to talk about. Good. So one of the problems with being in school is that the software you work on is small assignments, right? Small assignments, like you gotta start somewhere, right? But once you get out into industry, you're probably talking about programs that are maybe hundreds of thousands of lines of code, right? Very big programs, and you need some way to coordinate. Yes. The other way in which your typical school assignment is in no way like an industry project, once you have submitted your assignment, and I grade it, you probably basically never think about it again, right? You kind of throw it into the dustbin of your archive, and it's like, well, you know, you might look back reminiscingly on Java assignment 3 sometime when you're like moving files around. It's like, I remember that. That's not what industry is like. When you start a project in industry, those things can have a shelf life of several decades, right? The software must be written to be maintained, right? Maintenance of software is overwhelmingly the largest cost associated with it, not initial development, right? Which is why, as junior developers in industry, most likely you're going to be put on maintenance, not initial development. You want your most senior people working on developing the initial phases of the project. Unless you're like fortunate enough to work for a startup or something, get in on the ground floor, as they say. So, am I making sense so far?
No.
Any questions? No? Okay, good. So, yes. I just said all of that. Oh, one thing though. With your, another thing to consider, with your school assignments, you generally don't have to worry about like supporting all kinds of different operating systems or versions of operating systems or versions of browsers or anything like that. Whereas real projects in real industry do have to consider that sort of thing. So it's not only a matter of like the software as a monolith. You also have to consider versioning of the software itself, right? Which is another place that repository software comes in, right? So, this is a response to, from the internet. This is a random internet person. Random internet person responds to, how important is it to learn how to use Git? Critical. Git, or some other form of version control, is a tool developers use every day. If you've worked on a project of even moderate complexity, I'm sure you know how important it is to have a history of changes that you can revert to should things go wrong. Oh yeah, so that's another great thing about Git. If you keep a good history in a Git repository, if you screw up, break everything terribly, it's okay, because you can roll back to the last commit, and you basically only lose the changes you've made since the last commit. So, commit early, commit often, right? Failure to commit is commitment to failure. So, and if you don't know what committing is, that's another thing. I'm not talking about crime. We're not committing crime. We're committing repositories. Don't worry. All this terminology will be things we explore as we go through the course. I do not advocate committing crimes. Don't commit crimes, folks. Yes. Also, this bottom paragraph is also talking about how important branches are, which is what you were talking about, which is something that, again, we'll get to around the middle of the course. So, number one programmer excuse for legitimate slacking off. Hey, get back to work. GitHub is down. Oh, carry on. You literally can't do any work at all without GitHub, so Yeah. So, you know, much is made in recent years of the generative AI phenomenon, right? AI can write code. It's like, oh, do you think that a software engineer's job is just writing code? Ooh, absolutely not. Welcome. Developers spend about as much time doing operational tasks as they do actually writing code. So, you know, if you're wanting to know what the more AI-proof parts of your job as a software person, you know, in an era where the meme going around on the internet is CS is dead. If you wonder where your job is, you know, it's more than just coding, actually, right? This type of operational stuff will form a very important part of your function as a developer. So, again, if you were late to the class, the way that I opened this class was, welcome, you have selected the correct elective. This is the correct one, because this is going to teach you what you actually need to know to work and do jobs and stuff, right? This is the best one. Also, we get to do Linux, and Linux is fun. I don't care what other people say, Linux is fun. Yes, Dr. Moore, Linux is fun. So, when students don't know how to use Git, and they don't know how to use a command line, and they go out into industry, it can feel very overwhelming because you're basically plucked into a situation where you don't know how to use the tools the other developers are using to do their jobs, right? And like, to an extent, a certain amount of this is inevitable anyways, you know? Like, whenever you join up with an organization, they will have a way of doing things that you've never done before, and you're gonna have to learn their processes, right? But there's some stuff that we can teach you now, and certainly using Git is one of them, right? Bash. Essential job skill. This is one to watch as well. TypeScript has been gaining every year for quite some time now. So, good, wonderful. Any questions? Okay. We will also discuss text editors. You guys like VS Code? If you don't like VS Code, what do you prefer?
It's at least okay, I guess.
Yeah? Any Notepad++ fans out there? Yeah. You wanna see something funny? They've actually got a list of them here too. Dev IDEs. There you go. Notepad++. You thought I was kidding. Yeah. But I'd just like to point out Vim. Vim. Alright? You know what Vim looks like? Vim looks like this. This is Vim. Alright? This is the 5th most popular programming IDE. Visual Studio Code, it is not. We'll explore how to use it. Question?
Like 2 slides before, the last bullet point was about pipes and environment management.
Oh, yes.
I really want to know what pipes, because I heard it a lot, but I don't know what.
Okay, so to understand, I'll give you the quick version, all right? To understand what a pipe is, you have to understand that when you're in a command line environment, you are seeing standard output, the standard output buffer. You can take stuff that is sent to standard output and redirect it as standard input for another program. That's what a pipe is. So, we'll do examples of this, but like, for example, simple example, the ls command gives you a list of every file in a directory. The cat command shows you the contents of a file which you specify. If you pipe ls into cat, you get the full listing of every file in every directory. Make sense? So yeah, it's very, very powerful. But you know, we'll get there. Does this course seem interesting so far? Hope I'm not boring anyone. I'm trying not to bore you. So VS Code is nice. It does a lot of things, but sometimes, yeah, you remember me saying that, like, you will often be talking to computers that don't have a graphical user interface? Well, if it doesn't have one, then you don't have VS Code. And if all of your programming skill is wrapped up in just using VS Code, and particularly if all of your programming skill is VS Code's like autocomplete suggestions, then you will not be able to use text editors which are command line text editors. There are 3 primary command line text editors. I'm actually not particular about which one you use, though you should try not to use Nano for like heavy development work. This is another one of those unwritten expectations that the industry has for developers, is that you know how to use these tools, right? Basically, the question is, right, okay, I'm in an operating system. I need to do something with a file. I need to edit a file. I need to create a file and modify it. How do I do that? Text editor, right? This is, Copilot, yeah. So, it's also possible to use things like GitHub Copilot to do stuff like this, right? Generate code for you. Sometimes the suggestions are pretty good, right? Now, an algorithm like binary search is very well known. So, like, it's like, how advantageous is this versus like looking up an existing implementation of binary search in the language that you're doing, right? It's essentially the same thing. You're just like, it's just automatically looking it up for you. It's automatically looking up the reference material, right? One thing that you'll find out about me if you haven't had a course with me before is that I'm a bit of an AI skeptic. So, you know, I'm sure people have had. There we go. So, the operating system itself can be decomposed into 2 primary portions. The operating system is composed of eraser, there we go. Let's say this is the hardware. The next layer up from the hardware is called the kernel. The layer on top of the kernel is called the shell. All right? So when I say shell scripting, that is the shell I'm referring to. Now, an operating system may be running several shells. Right? Some of these shells may be command line interfaces. Some of these shells may be graphical user interfaces. One of these could be Bash. One of these could be the desktop environment. So far, so good? So, what is the kernel actually composed of? A lot of it boils down to things like standard library commands, right? So, have you guys heard of the C standard library? C standard library, anybody? You know about the C programming language, I presume? The C programming language? Well, Unix, the operating system, one way to think of it, which is not inaccurate, it was the first development IDE for the C programming language. Like, Unix is the development environment for C, right? It just happens that it's useful for other things too. So a lot of things, like, for example, your math library. Your math library, in pretty much any language you've used so far, you've noticed like the math functions are the same no matter where you are, right? That's because they're all implemented in the C standard library, right? The C standard library implementation of math functions is part of the kernel. In the old days, it was part of the kernel because your hardware would have a floating point accelerating coprocessor that the kernel would need to talk to instead of the regular CPU to accelerate these math functions. That's why the math function library is separate. That's why everything in the math library is a floating point operation. Every single one of them, even if they seem like they shouldn't be. But that's what the kernel is. Make sense?
Yeah.
Good, I'm glad. So, when we operate a bash environment, we are plugging into the kernel. We are kind of looking outside. The naming convention is supposed to sound like a seed, right? Or a kernel of corn. You've got the shell and you've got the kernel itself. Good. So, kernels provide application programming interfaces, which are services used by the operating system and other applications. These API services are accessed via system calls. When you open a file for reading, you are doing a system call. So, our application code uses library functions and system calls. The library functions may also use system calls. The system calls run off of the OS and the kernel. The kernel is ultimately running on the hardware. Make sense? So far, so good? Good. Within Linux, you have this concept of user mode versus kernel mode. An application can be in either user mode or kernel mode. User applications are basically anything that you are running directly, right? You are in kernel mode while you are calling kernel functions, making system calls. You kind of pop in and out of user mode and kernel mode, and it is possible in Linux to time how long you are in each of those. I'll show you how to do that. It's really easy. You just use the word time, and you make your call. I'll show you how to do it. It's cool. So, I said all of that already. So, graphical user interfaces are for non-technical people. Command line interfaces are for technical people, right? So all y'all should eventually learn how to use command line interfaces. I think 2 slides in there. Sorry, Kevin. This is a graphical user interface. I'm sure you've seen them before. This is a command line interface. This you may not have seen before. So this is Bash. This is a Bash prompt running on a computer whose name is Ubuntu. So the $sign is the Bash prompt. This is the symbol that you enter your commands after. For example, bash version. Make sense? So far, so good? Not breaking anybody's brain, hopefully? Good. So, I have already expounded on the virtue of command line interfaces, so I will spare you the agony. So you can say things that are very precise using command line interfaces. For example, find all hidden files that have file extension .png, including all subfolders. That's like one line. That's a one-liner. You guys want to, you care to guess what the command for that is? Take a wild guess. Find. The command for that is find. Yeah. ls lists all of the files in a directory, but if you're looking for files in a directory and all subdirectories, that's a bit more of a search, and find is the command you want. If you hadn't noticed, like, I've been using Linux for a little while. I would not consider myself to be an expert user, but I know a few things. You're in good hands. Don't worry. So I already did that. So, all right. Unix is a family of related operating systems which conform to a specification. Unix-like systems include systems similar to Unix, including Linux and Mac OS. Unix-like is not a technical term, but it basically just means not Windows. It means not Windows. Everything is either Windows or Unix-based, basically. Unix-like systems will share a similar modular design and characteristics, such as shells. Again, literally everything except Windows. Maybe some small stuff that nobody ever used, but, you know. So this is the great chain of the development of Unix operating systems. So I'm expecting all of you to memorize this for the test, for the exam that we're not having. Unix. Basically, the interesting points here are branching, but you'll see that the initial development of Unix occurred in the early 70s, early 1970s. The initial versions of Unix were branched off to produce PWB Unix, which eventually developed into such things as Solaris and Open Solaris, which is basically the only remaining extant one is Open Solaris. I think that, yeah, well, that's the only open source one anyway. After that, you had branching off for BSD. BSD was a pretty big thing. BSD eventually branches into, these are all of the directly Unix-derived versions. You'll notice that Mac OS, right, OS X, is actually a Unix, a direct descendant of Unix, whereas Linux actually isn't. So Linux was a project by a man by the name of Linus Torvalds, who I believe is Finnish. Yeah, I think he's finished. In the early 90s, he developed his own re-implementation of the Unix kernel. Unix, Linus, Unix, Linux. All right? Yeah, he named it after, well, he's since backed up on the claim that he named it after himself because it seems like quite the thing to claim, but he probably named it after himself. So the Linux kernel is completely open source from the beginning and eventually results in just an explosion of different distributions. And you didn't, this is from Wikipedia. Alright? So you've got some main families inside of the Unix family, or inside of Linux. Slackware, fairly early. Debian is one of the big three, right? The Unix, the VM that you have, the Mint VM, is a Debian derivative. Ubuntu is a Debian derivative as well. Lots and lots are Debian derivatives. All of these guys. Most of them are Debian derivatives. Red Hat is also a Debian, it's not a Debian derivative, it's its own thing. Red Hat and Red Hat Enterprise Linux kind of focuses on corporate customers. So your average Joe Schmo is, not that anybody who runs Linux is an average Joe Schmo, but if you have just a person with a laptop running Linux, they'll probably be running something Debian-based if they're less experienced, possibly something Arch-based if they're more experienced. But if you're a corporation, probably you will be using Red Hat or Red Hat Enterprise Linux, REPL or RHEL, RHEL. If you see RHEL, it stands for Red Hat Enterprise Linux. Fedora is a derivation from this tree. CentOS is a derivation from here. You have lots of them that don't go anywhere. Yes, yes, yes. Arch is in here somewhere, I think. But anyway. Any day when I get to open distrowatch.com is a good day. So, this is distrowatch.com. This is a website that measures how popular various Linux distributions are and provides information about them. This is the great big page hit ranking for, this is basically how popular are these operating systems, right? CachyOS, they've done some interesting things with respect to speeding things up in ways that I'm not sufficient to explain to you. But they're gaining popularity and for a reason, right? They've made some improvements that others are probably going to swipe. Mint is number 2. Mint is right now your good general purpose Linux operating system. That's why it's being used in this course. MX, I believe, is an Arch-based. Debian. Pop claims to be the gaming Linux distribution. So it's interesting it's that high on the list. Ubuntu is, people don't use it as much anymore, but at one point it was the most popular, about 15, 20 years ago. But yeah, that's the one that's run by Antifa, actually. Yeah, where's Alpine? Alpine. 28? Yeah. So Alpine is the one that generally gets put into, this is the one that gets put into containers, but like, this is not, like, this won't give you a good, accurate view of how popular Alpine is. Alpine is like way more popular than this list would suggest because this is just the number of people who visit the pages, right? When you're creating a container, you don't actually have to visit the home page for the distribution, so you download it and go, right? So this isn't going to be accurate. Don't underestimate Alpine, basically. But yeah, so that's Linux. Those are all Linux distributions. You gotta pick one though. And if you're gonna pick one, and you're not used to Linux, it's good to pick a popular one. So we're gonna do Mint. Mint is basically Ubuntu, but with all of the bloat taken out of it. Good. Wonderful, in fact. Let's see here. There we go. So Linux is open source software. This means that anybody who wants to can take a look at the source code, right? Anybody who wants to can copy the source code, make modifications, call it something else, and release it, right? This is why there are so many Linux distributions. But it's kind of like in this kind of open market, if you want to try out a good idea, then go for it. And if it becomes popular, it's normally because people, liked it, right? It's kind of like it's almost like a free marketeering version of, your operating system. But works surprisingly well. So, fun fact, the guy who founded Red Hat is from Ancaster, and he named it after a hat that he wore. That's how Red Hat got its name. And Red Hat Enterprise Linux is huge. It is a huge company that, like, many, many very good and important corporate clients. Like, a lot of people use Red Hat Linux, Red Hat Enterprise Linux. So this fellow has done very well for himself. Bob Young. So there you go. So it can happen to you. Canadians can be famous. Except, if you would consider him famous, he's probably still not, like, famous. Maybe some people would think he's famous. That's okay. Fame is fleeting anyways. So, alright. Shall we load up Mint? Shall we do this? Shall we do this thing? Alright. Hold on to your butts. Here we go. So this thing auto-opened, but I'm just going to close it. Alright, so VM. The application that you need to open is Oracle VM VirtualBox. This is a native installation on your computers because Mohawk Apps also uses virtualization. So you can't, you can virtualize within your virtualization process, but not with Windows easily. So, launch. Here you go. Oracle VM VirtualBox Manager. What we need to do is we need to import our virtual machine into VirtualBox. Import. Look for the file. I put mine in downloads, tool time, open. There we go. Next. Finish. Click through on the defaults. You'll see that we are now extracting, importing, doing stuff. We don't really need to know what or how. You can think of it as like, you know, unzipping the file or something. But yeah, once that's done, we will be able to launch the operating system. Is everybody following along? This is a follow along section, so. There we go. So you can see we have our virtual machine in our list of virtual machines now. To power it on, double click. Powering up. Ooh, are you guys getting excited? I'm getting a little excited. Ah, yes. So there are a couple of important things to know about running a virtual machine. Number one, it will attempt to take control of your monitor. This is fine. You should let it do so. When you want to get out of the virtual machine, you have to use what they call the host key. All right? So host key by default is the right control button. That's the one that most people don't use. If you use the right control button, I'm sorry, but you're going to have to train yourself to use the one everybody else uses. So, switch. There we go. Excellent. Yay! So, So you can see that, like, as you mouse over the window, your cursor changes, right? What is it? Home? Okay. Anyway, this will do. So here we go. This thing is an operating system, right? This window is an operating system. Where is, I think it's in over here. There's like a README. Yeah, there's the README. Instructions on how to use the image are included in the README. Important information like, what's the password? The password is the same as the username. Tool time. I don't know if this is a Tim Allen reference or not. Kevin is of the right age for it to be one. Tool time. Oh, come on. There we go. I always have to enter every crap password at least 3 times, even if it's easy. Yes. So we are now established. We have established a connection to the internet. So, Firefox, there you go. My canvas. Oh look, it's just the internet. Right? You can log in with this and everything. You can do all of the browser stuff inside the VM as long as it's on a computer with a network connection. So far so good? But we did load a VM just to be able to run a browser. Oh, and by the way, when you're clicking X, try not to click that one. So, let's see here. So, let's talk about bash. You want to know what bash stands for?
I don't know what it stands for.
Oh, but you want to know.
Yes.
I love the enthusiasm. It's the Born Again shell.
Born again.
Yeah. So you had an earlier version of that of bash, which was called the Bourne shell, Bourne, because it was like a guy's name. You know, not the what's the movie like?
Born conspiracy.
Yeah, it's not. There's no conspiracy involved. It's just the Bourne shell. But this is like a new version of the Bourne shell that supersedes the old one, so it's the Born Again shell, bash. There are other shells that you can access, such as Z shell, ZSH, corn shell, KSH. These are shells that you can actually you can load from other shells. They work like programs. So, for example, my Mac users, if you have a Mac in front of you right now, go find the program terminal. When you have found the program terminal and launched it, type into the terminal bash, and you will be able to follow along with us. So, bash is definitely the default shell on most Unix distributions, or Linux distributions. The only place that it, like, you know how I was talking about Alpine, right? Alpine is like too stripped down even to have bash. So it has like a stripped down version that's just sh or just shell. So, you know, most of the time you'll have bash though. You can even get it for Windows using the Windows subsystem for Linux, but we're not going to do that because Windows is stinky. Alright, so, wait, before I get there, let me show you how do you access terminal. Well, you can either use the icon like a chump, or you can use the hotkeys. Control-Alt-T, like a winner. There you go. So this is a bash terminal. You now have the whole universe at your fingertips. So, you know that command that we saw earlier? Bash, dash, dash, version? There you go. Tells you what version bash is. So far, so good?
Yeah.
Very good. So, when you enter stuff in like this is called a bash command. Bash commands are programs. Programs such as the programs you have written in this program so far. By program, in that case, I mean this college diploma program. So, okay, you can write a Java program to do something. Sure. But can you write a program to use that program? That's the question. Now you will be able to. Oh, maybe I need to increase the magnification here for a moment. Can I do that? View, zoom in, Control, plus. There you go. There. Is that better to read from the back? Can you read that at the back? Is this even better? Yeah? Okay. There we go. All right. So, good. We're going to go through these in order. Here is an example of some, like we'll do all of these in the shell, just like be patient. I want to explain to you the structure first. So each of these are commands. Cat, cd, man, ps, pwd. All of these are commands. The way that you use a command, you simply type it into the prompt. So for example, pwd is print working directory. It tells you where your prompt is currently located inside of the file system. Most commands that you use will require arguments. This is an argument. If it has a dash in front of it, or two dashes, it's called a flag. So, for example, if I use ls to list the contents of the directory, that's fine, it does so. If I say ls-a, I get something else. The A flag shows me all of the hidden files as well as all of the non-hidden files. So basically, the flags are a way of passing options to your command line programs. Every command has different options that do different things. It's highly dependent on the particular program. A few of them are like kind of universal, like -v is usually verbose mode, which means it prints a lot more of its information to the screen than you would otherwise get in like quiet mode, right? But yeah, that's what a flag is. Does that make sense? Good. So, I said that the motto of Linux is read the manual. Let me show you how to read the manual. The man command, followed by the command that you want to look up the reference for, will bring up that reference. So, for example, man pwd. User commands name, print name of current working directory. Current/working directory. You can see it has a couple of options, but the program is so simple that it doesn't need very many, right? One of the design philosophies of Unix, and I mean Unix, not Linux here, is many small programs with a common interface. Many small programs with a common interface. PWD is a small program, but that doesn't mean that it's not important. Size isn't everything, right? Yes? So, if you want to look at the man page for some, oh, and by the way, get out of here, you. If you press Q on a man page, that exits back to the terminal. If you look up the man page for something a little more complicated, like CP, you'll see that you've got quite a few more options. CP is a command for copying files from one location to another. So, make sense? So far so good? commands can have arguments which are not flags. The majority of the time, these will be file paths, or file locations, or other things. For example, glob patterns. That's G-L-O-B, glob pattern. It's probably short for global. Early Unix had this interesting thing where like commands could only be so many letters long, so the really old ones are like, you know, the terminology is just something you get used to. So for example, touch. What does the touch command do? It creates a file. Who told you that? I'm impressed. Who knows? Who knew touch creates a file? Yeah, there we go. So touch creates a file, but it requires the name of the file you're creating. For example, test.txt. You can see that test.txt now appears. Do you know what else touch is used for? All you people who knew touch exists already. Updates the timestamp to the current time. If you touch an existing file, it updates the timestamp to the current time. And with certain flags and options, you can use touch to touch up the timestamp of a file to a time in the future or the past. Because this is Linux, and you can do whatever you like in Linux. So, you know, when in the past, when I have said to students in client side, this seems to happen to me most frequently, and oh, but sir, you can see by the timestamp on CS Unix that I got my submission in on time on CS Unix, even though I didn't submit it to Canvas. It's like, that's a Unix server. You can do whatever you want on that. That doesn't mean anything. You could have adjusted the timestamps very easily. So yes, but you can see the structure here. Touch, file name. You can also use file folder paths. Space is carrying a lot of semantic weight here that it doesn't usually, right? What the space character does in Bash is argument application. So a space means this is an argument, apply it here. Make sense? This is why you don't include spaces in your file names. Did my mic just go out? Oh man. Hello? Test, 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 test. Yeah, I've got the little red battery light. I guess I'll just have to shout at you for the rest of class then. So when you are working in Linux-like environments, please, please, please do not include special characters in your file names. Hyphens are okay. Underscores are okay. Dots, you can use more dots than you probably think you can use. Don't use spaces. Okay? Everybody's making a solemn pact with me right now not to use spaces in their file names? Okay, good. Because that is one thing that annoys me to no end. So, and you can see the reason why, I hope. Take this example here. If I replaced this underscore and that underscore with spaces, I would not be applying two files to this program. I would be applying 4, right? Which CP doesn't know what to do with that, so it'll crap out on an error for you. Make sense? Like, technically, you can use spaces if you backslash, like if you escape them. But why would you want to if you could just use a hyphen and not have to escape the character, right? Cool. All right. Question.
What do you mean escape the character?
Oh, simple enough. You know Newline?
Yeah.
When you provide a backslash in front of a character so that this character is no longer an N but some other operation, that's called escaping it.
And how would you do it in a command line? Is a backslash
Just the same.
space? Okay.
Yep. You'll notice that even ls is like, I'm just going to put some quotes around that for you, because clearly you're new around here. So, any other questions? That was a good question. I rarely tell students that they have bad questions, but you know, that was a good question. So, there is such a thing as a bad question. And also, while we're on the topic of dispelling common myths, I should put my email in, but how do you like my biography? If you want to know about me, then you should have a conversation with me. That's what I have to say. So, we're going to get more into the nitty-gritty now. We'll be going through these in the order that they're presented in this. Am I gone again? Yeah. We'll be going through these in the order that they're presented in the slides, but you know, this is a lot of information, and the only way you will absorb this is by practice. Not all of these commands are going to be ones that you practice a lot. My humble recommendation, wherever you do your work, in your home or wherever you live, if you don't live in your home, you should make for yourself, and I emphasize you should make for yourself a quick reference sheet of Linux commands. You should paste that up wherever you do your work because you'll need it. Don't get one off the internet, just make it yourself, right? It's not that much work. Start with this. Anytime you use a command and it's useful, put it on your sheet. You should, by the end of the semester, probably have like 4 or 5 of them all around your work area, and that's how you know you've been in this class. If you take those and you take them to your first job and you put them all up, people will respect you. So, uname, depending on what commands you put on it, of course, because they'll read it. They will absolutely read it. Uname gives you information about the system that you are currently on. This is useful if you just SSH'd into something and you don't know anything about the computer you just connected to. Uname. What is uname? Uname is Linux. Haha. All right, how about a bit more? There you go. The A flag gives you a bit more detail. You can tell that, well, tooltime-virtualbox, so you're pretty sure you're in a VirtualBox instance. Here's your version of Unix. Here's the version of Ubuntu that's based on. I think that might have been the time of creation, your architecture, all kinds of useful stuff. This is your computer. So far, so good?
Good.
Good.
It's created, why is it Thursday?
Probably because the virtual machine was created on a Thursday.
Oh, I thought when you say creation, I thought you meant when you created this virtual machine, like the...
Oh, actually, that's an important point. Loading it is not at all the same thing as creating it. Creating a virtual machine is actually a really good exercise that I would encourage all of you to try on your own time. I don't think it's in the notes. Go to a Linux distribution webpage of your choice, download the ISO, load that ISO into VirtualBox, and try to spin up your own virtual machine. It's a really good exercise. I already showed you pwd and man. Prints the current working directory. This is very good if you get lost. It's easy to get lost. Man gives you the manual, the man page for whatever command you enter. So man pages can be difficult to read. They are made for, they're made for people who know what they're talking about, right? So they can be a little intimidating for beginners. But to quote XKCD, life is too short for man pages, but occasionally too short without them. It's definitely okay to read other stuff other than man pages. Stack Overflow is fantastic. I've already commented on how rando internet blogs are increasingly not what you want to go to. You might also just want to, get a textbook, shell out for reliable information. This is kind of the feeling and impression that I'm getting over time is that accurate information is going to start being worth money again, because the amount of time that people are going to waste going through all of the slop output of the AI to try to find something that works, it's like a good solid desk reference of the information you need concisely stated. It probably has enough value to be worth paying money for it, right? This may not have, this future was not inevitable, but I think that's the timeline we're on, if that makes sense. So, apropos. Apropos is a search command that searches man pages. If you are looking not only for, the man page on a particular command, but all other commands that reference that command, this is one way to do it. So, for example, apropos ls. ls might be a little, you can see a lot of things use ls, right? Including ls itself, right? pwd. pwd is used by fewer things, probably because it's so simple, and honestly, I'm pretty sure that all it does is echo an environment variable. That's okay. So far so good? Any questions? Okay. This is a cool one. Okay. Ooh, wait. Yeah, excuse me. Here we So, sudo is the command that elevates your level of privilege. By default, all of you are at regular user level privilege anytime you're doing something. If you need to do something with a little more power, a little more force, you invoke super user. This is roughly the same thing as administrator mode in a Windows machine, except that it works and makes sense. So, I just had the unfortunate task of explaining to a bunch of server-side students before I came to this class that, like, XAMPP, you know XAMPP, the thing XAMPP? It's all of its stuff is in, like, the public area of the computer, so if you leave your assignments lying around in there, people can just yoink them up and you get an AD charge without having known you had done anything wrong, right? And if that didn't happen to you, thank your lucky stars, and maybe go to the computer that you used to use in the lab last year and just make sure that XAMPP has been cleared out. I have seen assignments in there from previous semesters on those lab computers. So that's an example of a user permission system that's not working very well. Linux has a good user permission system. If you don't have, it is possible in Unix to restrict someone from reading or writing a file if they're not in the right user or in the right user group. Users in Unix either have admin privileges or they don't. They either are a sudoer or they are not. If you're not a sudoer, then you can't sudo. Right? Good example, CS Unix. None of you have sudoing privileges on CS Unix. If you did, other students' private directories wouldn't be very private, would they? Right? I don't have sudoing privileges on CS Unix. Only IT has sudoing privileges on CS Unix. So basically, this leads to this, the thing that this is parodying is that essentially what happens is you'll ask for a command that requires super user privileges. The terminal will say no, and you'll say same thing but sudo, and it'll be like password. You give it the password, and then it's like, yeah, okay, here you go. Here, I'll show you. So, one of the things that you can't do as a regular user is play with the operating system, right? This makes sense. You shouldn't be able to play with the operating system. This is where your operating system is located. CD is change directory, by the way. CD/, that is the root of the operating system. Tilde means home, by the way, home folder. / means root folder. This is the operating system. If I want to, I don't know. Let's even go into root. Oh, I can't even go into root. There we go, there's a good example. I'd like to see root, please. Bash CD root permission denied. Sudo CD root. Password. Tool time. There we go. Command not found. go. There we go. Sort of. It still didn't let me in. Oh well. Let's see here. I probably can just. Can I like just touch a file? There we go. That's something I can't do, and I should be able to do. All right. Sudo touch a file. There we go. ls a file. Ta-da! You should not leave files lying around in the operating system. Don't do this. Okay? But you can, because it's Linux. Question.
Why do we not leave files in our operating system?
Cleanliness? Like, honestly, the operating system will ignore it because it doesn't refer to anything, but like, because it'll make me squirm if you do it. It's like, just don't, just hands off. Hands off all this stuff. Don't, unless you have good reason, don't go in here, okay?
Would a prank count as a good reason?
A prank? No. If you're gonna do pranks, see the thing that distinguishes a prank from like an act of monstrosity is that like the prank is like an innocent little jibe and like not permanent. Here you are permanently like cluttering up the operating system. So this is an act of malice, not a
Like a command to undo it or something?
Oh yeah, well the command to undo it is this, rm a file. Remove, it's write protected, yes. Cannot, permission denied. Ha!
Did you do like a sudo rm?
Sudo rm, yes. But now you see we're traveling pretty close to, you know, remember that command I put on the
Yeah.
that deletes the whole operating system?
Yeah.
There's a reason for you. Because to undo your madness, you have to do things that seem pretty similar to like deleting your whole operating system if you're not careful. I'll do this carefully, guys. Sudo rm. So one thing about sudo, once you've entered the password once, I believe it's about 10 minutes it gives you in super user mode where like you still require the sudo command to do something as super user, but you won't be asked for the password again for 10 minutes. Does that make sense? Are there any other questions? Since we're here, most of this stuff is stuff you don't have to worry about. Home is where your user directory is kept. So that's like where your home is. Boot, don't touch boot. You guys know what the boot sector is? Okay. So you know when your computer is off and then you turn it on? That's called booting. All right. So boot is short for bootstrap. There is a very small program that loads the operating system itself. That is the boot that's boot. That's what that is. So if you mess around with the boot loader, God help you.
You might not.
Well, you probably won't brick the system. But the fact that I've started that sentence that way means you should be careful, right? You probably won't brick the system, but you'll probably need to reinstall the operating system. Which means losing everything on the operating system, including all of your files and everything. So Git, back it up to GitHub. Your whole operating system, just have it one big Git repo. Yeah, so don't touch boot. Etc. is where some programs are kept. Programs are kept in a couple of different places. Bin stands for binary, that's where some file binaries are kept. Media is mount points for USB drives and stuff. So when you plug a USB drive in, a folder is created in media corresponding to the thing you just plugged in. That's called mounting a drive here, right? You mount drives and you unmount drives. That's the terminology. Root, I'm not even allowed to see what's in there, so who knows. User, also program files. Var, some program files as well. Opt. Opt is like, actually xamp goes in opt. This is like a certain class of, like, stuff goes in opt if it's like the stuff that would get stuck in your C drive on Windows. So, all right, very good. Moving on. Yes, 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 good, good, good. Apt. Apt. Apt is your package manager. Apt is the way that you get programs.
Yeah, so I
Yes.
was curious, since you said before we can't really do anything, then after we added sudo, everything had permissions, right? Like, how many levels are there to it?
There are only two levels of permission. User mode and super user. You're either super user or you're a regular user. There are only two levels. So, sudo apt install tux cart, is that the name? Super tux. How about super tux? There we go, super tux. So when you ask to install a program, oh, by the way, tab is like autocomplete. The button, I sometimes do this stuff without even realizing I'm doing it. To bring up like available options and stuff, tab is normally the thing. If you ask to install a program, it will say, do you want to continue? This is how much disk space it will take. Yes, thank you. Downloading SuperTux. Oh. Yeah, SuperTux 2. Sorry, SuperTux guys. There you go. The cursor really creepily looks at you when you click. Anyway, we're not playing SuperTux, but that's, you can get Linux programs. Not just games, but you can get some games too. So, apt is quite complicated, actually. What it actually is a very, very complicated system of interdependencies that it figures out for you so that you don't have to when we installed SuperTux, just there, right? Let's take a look here. We imported many software packages. libfizz fs1 amd64, fonts nanum, fonts roboto unhinted, libglue 2.2, supertux data, supertux itself, right? Apt is what you use if you don't want to have to figure out the dependencies, right? So when you are installing software, use apt. Most of the time when you want to install something, if it's not in the apt repository as already, they'll give you some kind of something compatible with apt as a download that basically does this, right? This is like the main way of installing software. Does that make sense? Good. Flatpak is another alternative that has been gaining some traction in recent years, but apt is sort of the king. But it's also specific to Debian. So if you're in other distros, there will be other there are other things that do the same thing apt does that are not called apt. I think the one for Mac is called brew. Brew, I think. Yeah. Yeah. Make sense? So basically, before you install anything, you should update the apt registry of what has updates and what needs what. This updates like what dependencies are required for what according to like what the current state of the network is. So run update before you install anything, unlike what I just did. Especially if you're using the VM, because the VM was created like a couple of years ago. So you should update the cache. Make sense? So far so good? Question?
What is the directory that apt is reading from? Is there like an overall library that we can scroll through and see what like all the different programs are? Is it just, does it have a specific store, quote unquote?
There is a local store. I don't recommend looking at it. I recommend looking at like there's a website that'll tell you what all the app repos are and what they're up to date with. Like that's what you want to be reading. And generally, like there's so much in there that you generally don't have to be concerned with what is in there, unless you want to see the list of games, of course. But you shouldn't need that unless you have a reason to go into that.
So is the use case usually that you have something that you need and therefore you know you need to install it through app and then you do it? So it's not, you have the thing you need before you install it, not the other way around?
Yeah, sort of. The usual thing is like, I want X software. I go to X software's website. I say, okay, downloads, and they say for Linux users, just apt it. Here's the thing, and you're like, oh, thank you so much. And if it's not that, it's like downloading a .dev package, which is basically the same thing, although a bit more annoying because you have to do more of it manually. Sometimes they will require you to like add a repository to apt that's not in apt's list of accepted repositories, which is a little bit of a fussy thing, but like you copy like 2 or 3 commands off their website, run them, and it's in apt. The other thing that's nice about apt is that it's hooked into the software manager. This dude here, right, the update manager, which just tells you when you need updates. It is not like Windows Update, not at all. Okay, quick survey of the class. How long does Windows Update take you? 30 minutes to an hour? Anybody for whom it takes like a day?
Sure.
You know?
Used to.
I have never had even a kernel update. Kernel updates are like updates to, you know, the operating, the middle, the gold nugget at the middle of the operating system. 2 or 3 minutes. And that, you should think of that as like a proper new operating system version. It takes a couple of minutes. If I haven't convinced you to ditch Windows by the end of this class, then I have not done my job. Okay? But in all honesty, like for all of your images that you've downloaded, if this is the image that you're keeping and you're not going to re-download it, like, yeah, just update it, get it up to date. Just do it here. It's the little shield icon here. It's fantastic. Just do it. There's no reason not to be running the latest kernel. And if everything breaks, you can always just re-download the VM. So, Emacs.
No, the game is broken, I think.
Did you? Is it broken?
Yeah, like it's just on the game, Super Tux is press escape to skip, it's not really skipping.
Well, I mean, yeah. It's not important to your grade in the course that you get Super Tux working.
Like, when we did, I kinda did it, but mine was just still loading, it was just loading, it took like around like 2 to 3 minutes, to finish loading.
Well, it's a good thing I didn't go for a Tux cart then. So, this is like one of your commands that you will use, like, you know, maybe 6 or 7 times every time you sit down to do anything, right? ls. ls lists the contents of a directory. In order to work with the stuff in a directory, you have to see what it's called. This is how you see that, right? I've already used it a few times. It has a couple of interesting options. Is that okay? Can I work like that? Is that okay, guys? Yeah? Okay. And maybe like take that off, make this smaller, make that larger. There we go. So, ls-l. Oh, am I still in root? There we go. Change the phone. ls-l gives you a more detailed view of all of the things in your file, or in your directory. Owner, the group the owner is in. File size, you can see that directories are always 4 kilobytes. Date of last modification, you can see this thing was basically created January 5th, 2024. The name of the thing, and your permission groups, whether you have read or write access to them. Make sense? F, the capital F flag, puts a slash here. You may be saying to yourself, okay, why? Not all interfaces that you will use do the nice color coding job. Oh, I didn't explain. So, blue is a directory, white is a file. If you see anything green in here, that's something with executable permissions. We'll get to executable permissions reasonably quickly, actually, because we're going to have to talk about scripts, and scripts are executable files. So, folder, 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 file, file, right? The folders aren't always going to be blue. If they're not, that's how you see which ones are which. Right? Good. Sort by file size, descending order. LRT, sort by modification time, oldest order first. I want to make a joke about the LRT, but perhaps I should move on. So, file paths. This is like also very, very important. There are 2 ways to refer to a file: relative and absolute. So if I have, where are we here? So if I use the cat command, cat just shows you the contents of a file. I guess test, neither of these files have any content, so it'll just do nothing. Yeah, but it still works. So cat allows me to test that, to do something with that file. I can also get to that file from the root of the operating system. You can use tab to autocomplete paths, right? This does the same. I should give that thing some content. Just give me a second. Test.text. Ta-da! Ta-da! I'm reading the same file, but I'm getting to it two different ways, right? Now, I should let you know another little trick that I used. Arrow keys. If you use the up and down arrow keys within the bash prompt, you are scrolling through your history of bash commands. This can be very useful because typing out commands is tedious, and if you've already done it, why do it a second time? Just go back to where you entered it previously. Come on in. Right? So that way, if you want, you can enter the same command multiple times by just kind of flipping between up arrow and enter. And you can do that quite quickly, even with one hand. Make sense? So far so good? Any questions? So, like the file system, you should think of the bash prompt as being embedded at like one point in the file system. The file system is where you are located, right? At all times, you have a current working directory. That is where you can say this prompt is located. All of the files that are local to that directory can be accessed, by just using the file name. But if you want to access something in a subfolder, you can do that too. So ls, by default, shows me the contents of this directory. If I want to say, let's say ls, what's going to have something in it? Templates? Templates has nothing in it. Music? Music has nothing in it. Downloads? Has nothing in it. Documents? Give me something. Pictures?
Oh my god.
Nothing. Okay. Change directory, documents, nano, this file, save, exit, cd, back, there you go, ls, documents. There, we've got file. File exists in documents. If I want to read the file, I can say documents/file. And there is the file. Yes?
What is the nano command doing?
Nano is a text editor. So the nano command, and don't worry, we're going to get to it. Basically, there are 3 command line editors that are we talk about in this course: Vim, Emacs, and Nano. Nano is the most basic and user-friendly of the 3. It's user-friendly because it actually tells you what its commands are. Nano, let's just take a look at bash RC, hey? So this is Nano. This file is now open for editing. It works a bit like Notepad. It's like Notepad but with syntax highlighting. It's somewhere between Notepad and Notepad++. It gives you what your common commands are, though, command shortcuts along the bottom of the screen. So this is like Control X is exit, Control R is read file, Control K is cut, Control U is paste. Does that make sense? Question?
What's Control T?
Control. sorry, T, execute. You know, I've never used it, but it's probably like run this thing.
Okay. Can you run like bash scripts?
Yeah. Let's do baby's first bash script. Nano first dot sh. Dot sh is like your general thing for bash scripts. All bash scripts
I thought so.
such. It starts with the shebang. Bin bash. That tells the computer what program we want to run this script. You don't have to use bash. You can also use Python. You can use KSH. You can use whatever, you know. This tells it what program this is a script for, right? PHP, anyone? Actually, I think that semicolon's optional. Now, you can't just run it. This is how you run something. / first dot sh. Permission denied. So you're like sudo first dot sh. Password? Sure. Command not found. So it's not a command. It's not an executable program, right? But this is Linux. We can do whatever we want in Linux. A little program called chmod, if you will, modifies the permissions of files. If I want to add executable permission plus x, first.sh, you may now see the file is in green. Green file means it's executable. I may now execute it. Your first bash. It's very common thing. So, that's how you do it. That's how you can make a bash script. We'll do this at some length later on.
Okay.
But those are the basics to get it working. So within this file, nano first sh, in here, you can literally put any bash command. One command per line, that's the rule. But you can literally put any sequence of bash commands in here and execute them as a script.
Okay.
You may begin to see why this is the 5th most popular programming language. Even though it's really quite ugly. Like, as languages go, it's really like clunky and antiquated and does a lot of really, really strange things. Yes?
Can you use nano in any directory?
Yes.
Or any file? Okay.
Yeah. Now, if the file's big enough, you know, you should either break it into smaller files or you should, you know, use something maybe a little bit more beefy. Nano, again, is one of 3 text editors that we're, you know, suggesting here. Why don't I just pull up the slide on it, since we're talking about it. Here we go. So Nano is the one that I just showed you. It's the most basic and user-friendly one. The other ones that you might consider are VI/Vim or Emacs. So Vim will come prepackaged. Emacs you'll need to install using apt, right? I'll show you what both of them look like. There's a comic on text editors, which I won't read because we're running short of time. Just pick one, and stick with it, but not Nano or Emacs. This is Kevin's joke. The joke's on Kevin because I'm actually an Emacs guy. Emacs is the text editor that thinks it's an operating system. So, there we go. Oh, I gotta install Vim now? If I must. Yes. What a right royal pain. This is VI/Vim. Your cursor is not initially in edit mode. You have to put it into edit mode by pressing I. You'll see you're now in insert mode. You may now modify the file. In order to save the file, it's escape : S, no, sorry, what is it again? Oh man. Right, W for right, yes! Escape : W to save the file. Escape : escape, come on. Yes, yes, yes. Insert mode. Escape : Q to quit. There's a lot in Vim. Lots of stuff that I don't know how to use. Maybe we'll learn together. I know a bit more about Emacs, which I'll also have to install. Emacs is written in Lisp. That's a very old programming language. Lisp, Emacs is like the only program still running Lisp. But hey, it's downloading faster than Vim did. Oh, never mind. Oh, don't tell me you're going to do all the language packs.
It's pretty fast.
I might, okay. So I will show you a beautiful thing about terminals. You can have more than one of them. Oh, look, that one finished, okay. But you can have more than one terminal. Yay! All right. Emacs then. Oh look, it brought up the GUI version. Emacs. Yeah. I forget how to force Emacs into terminal mode, but it's basically this but in terminal mode. Yeah. So basically, a lot of these editors work on like combinations of like Control or Alt with a single key on a keyboard, which performs an operation or function, like save the file, load the file, quit the program. In Emacs, you'll often have to provide two of them, like Control X, Control S is save, Control X, Control something else is quit. Yes. So text editors, yes.
Just a little side tangent. Are the commands you've learned today, are we able to use those on Windows PowerShell?
No.
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 Just specifically these bash terminals?
Yes.
Okay.
And even if you're using something like Windows subsystem for Linux, I'm not guaranteeing that anything here will work there. Particularly things like apt
Okay.
probably won't work. So mileage may vary. There's a reason that we're asking you to do this course in a VM. Well, looks like we're out of time. That's okay. We'll finish up these commands next time. That's quite a lot of information anyways. I'm sure you're all exhausted. Thank you very much for your time and attention, folks. Please, have a careful commute home this late at night.